You're welcome to the Scholar School. We establish our footprints on the sand of time, experience the difference.
Welcome to the class for today. Now we have our physics here. The topic we have vector. You know, it is not. I don't like count it as maybe probably a new topic because most of us might have like come across this one way or the other. So I want to like ask the question: do we have anyone here who have any idea about vector? Vector. Any person here? No. Now, what exactly is this vector? Now, this vector here is talking about quantities having both magnitude and direction. It's talking about quantities having magnitudes and direction. Now, let us explain. If I move from point A to point B, number one, I've done two things. I've covered a distance AB in a specific direction. I move from point A to point B. Now, if I want to like take a look at like probably follow what I drew here on the board, that means I move in the what? Eastward direction. Yes or no? That means these are four cardinal points. This is our east. That means I move eastward direction from point A to point B. Now, point A to point B can be measured. That is what? The magnitude. In what direction? The eastward direction, which is this direction. Are we getting this at all? So that is a perfect example of what? Of vector quantity. Now that means vector quantities are quantities having both magnitudes and what? And direction. They have just two things. But we also have another thing. That is the opposite of vector quantity. We have it to be scalar quantity. Scalar quantity are those quantities having only magnitude. Scalar has only what? Magnitude, but no what? Direction. Vector has both magnitudes and what? Direction. But scalar has only magnitude but not what? Direction. For example, scalar quantities, we can have it to be what? 3 degrees Celsius temperature. You cannot tell me that this pot is what? 90 degrees Celsius hot. You now give what? Direction? Hot to the east. Have you ever have you ever seen anyone say that? No. Why? Because that is a what? Scalar quantity. It only has what? Magnitude, but no what? Direction. You can't tell me that Bolaji's height is 75 meters north. You'll be like, what's wrong with you? Why? Because that is a scalar quantity. So it only has what? Magnitude, but no what? No direction. But here we'll be discussing more on what? Vector quantity. Why? Because there's something we are going to discuss about here. Now, there are different ways of calculating some certain things here in vector quantity. Vector quantity. There are different ways. We have a graph here. Two vectors moving in different directions. I call this my x. I have this here to be y. Having an angle to be A. My angle here, theta. This line here, I have it to be A. Now, when I try to form a kind of open lines here and likewise here. Now, the length from here to here becomes my what? My AY. From here to here becomes my AX. We are trying to generate a formula here. Now, if this is my AY and this is my AX and this is my A. Now, using this theta, I want to generate what is AX and what is what? AY. We all have this basic knowledge that what? Opposite over hypotenuse is for what? Is for sine. We have knowledge of our so, our can, then our toa. Now, these three things are what we are going to use to generate formulas under what? This vector. Now, let us start with the first one. We are looking for AY. AY has a relationship with our hypotenuse. AY is our what? Opposite. Our hypotenuse here is what? Is A. That means we can generate a formula here, which is what? For sine. That means sine theta is equal to what? Opposite, which is what? AY over hypotenuse, which is what? A. Are you getting this in at all? Now, when you make AY the subject of formula, it becomes what? AY equals A sine theta. Write it, equation 1. Now, go back to what? AX. There's a relationship between A and AX. AX is our what? Our adjacent. Our A here is hypotenuse. Adjacent hypotenuse, that is what? Cos. So we have cos theta to be equal to what? AX over what? Over A. When we make AX the subject of formula, you have AX equals what? A cos theta. And these two formulas are two things. Number one, this AY is called the vertical component. Vertical component. While this AX is called the horizontal component. AY is called the vertical component, while AX is called the horizontal component. Now let us finalize it. We have TOA. TOA is what? Opposite over hypotenuse. What's my opposite? AY. Opposite over adjacent rather. TOA, which is tan, is opposite over adjacent. AY, my opposite. AX, my adjacent. That means tan theta equals what? AY over AX. Now, by the time we start solving questions, we are going to get this well. Now, let us solve some examples. When we have vector, for this tan theta, if you are asked to find the angle that both like this angle here, angle theta, that is when we use our what? Our tan theta. Now, given vector A to be equal to 2I plus 4j. 2I plus 4j. Probably let us use let's still use our 4j. Now we have 2I plus 4j. Now there's one thing about vectors. We have dimension. It says it also has dimension. Now that means we have vectors in 2 dimensions. We likewise have vectors in 3 dimensions. Vectors in 2 dimensions has only what? I and j. While vectors in 3 dimensions has I, j and k. Vectors in 2 dimensions has I and j, but vectors in 3 dimensions has I, j and k. Now here we have a perfect example of what? A 2-dimensional vector. Now if I want to find my what? My AX and AY, it will just be like as if I'm wasting my time. Why? Because I have it here in my question. This A you are seeing, this is it here. That means they are telling us, fine, let me complete, find AX and AY. Now, to be able to solve this question, I have my A here. Now, AX simply means what? A cos theta. I don't need to start writing A cos theta because A having a general formula to be what? AXI plus AYJ. This is it. That means here, automatically, I have what? A to be what? AXI plus AYJ. And I have my question to be what? A to be equal to what? 2I plus what? 4J. What do I need to do? I compare. A is A correct. I here, that means AX is equal to what? 2. I write it. My AX equals what? 2. Now, AY is what? Equals to what? 4. So, this is how to locate them. That means the what? The vertical component AY is what? Is 4. And the what? Horizontal component AX is what? Is 2. Are we getting this thing at all? And if I now ask you to find the what? The angle of A, what do I need to do? I'll just write tan theta equals what? AY, which is what? Which is 4, divided by AX, which is what? 2. And I have my answer. Are we getting this thing at all? Now let us move on to another thing about vector. We have the addition and subtraction of vectors. Now, addition and subtraction of vectors. Now, I said something earlier about the 2-dimensional vectors and the 3-dimensional vectors. Now, the addition and subtraction of vector here is not talking about adding 2 or more vectors together and subtracting a vector from another vector. Let us say, for example, vector A. Can anyone give me an example of vector A? A 2-dimensional vector, or probably 3-dimensional vector. Okay, that is 6i, yes, plus 12j. Correct. Now, I also have my vector B. Can anyone give me another 2-dimensional vectors for vector B? 8i plus 12. Let us use another one plus 6j. Now, 8i plus 6j. Now, this is a what? 2-dimensional vector. Now, when it comes to addition and subtraction, the question could just be find what? A plus B. A plus B is telling us just add the two what together. That means you are going to have what? 6i plus 12j plus 8i plus 6j. So I have this. Now what do I do? 6i plus 8i, then 12j plus 6j. 8i plus 6i plus 8i will give me what? My 14i. So I write 14i plus 12j plus 6j will give me my what? My 18j. And that's my final answer. Now, let us still solve another question from here. What if the question says find A minus B? Everybody, are we seeing this at all? Find A minus B. That means we have what? 6i plus 12j minus what? 8i plus 6j. That means we are going to have what? 6i plus 12j minus 8i minus 6j. Are you getting this at all? That means you have what? 6i minus 8i. That's what? Minus 2i. So we have minus 2i. Now 12j minus 6j. That's what? Minus 6. That will be what? Plus 6j. So this is our final answer. So here we have 2i plus minus 2i plus 6j. And that's all about what? Addition and subtraction of vectors. Now, there are some certain times you might be given like 3-dimensional vectors. Now, let us solve another example. Under 3-dimensional vectors. 3-dimensional vectors now. When I have vector A to be 3i plus 4j minus 6k, you can see it now. Then I now have another vector B, but this vector B is now given in 2-dimensional vector. Maybe 4i minus 2j. Now the question now says find what? A plus B. Everybody look at this. A plus B. How are we going to solve this? You know, it's still the same way we solve this that we are going to solve this. But there is a question that might arise. What are we going to add k with? Yes or no? Now, what do we now need to do? Let us now rewrite this. That means our B here is equivalent to 4i minus 2j. K is there, but plus what? 0k. Are you getting this thing at all? Plus 0 what? K. Then our A, we have it here. So you can now add A plus B to be equivalent to what? 3i plus 4i. That's what? 7i. 4j plus minus 2j. That's what? Plus 2j. Are you getting it? Then minus 6k plus 0k. That's what? Minus 6k. And this is how to add vectors together. That means vectors in different dimensions. Adding them together, this is what we do. Are we getting this in at all? Are we getting this in at all? Now, what if they now ask us to subtract? That means A minus B. A minus B. Now we have what? A, which is what? This. And we likewise have B. Now let us subtract. 3I minus 4I, that is what?
Minus 1i.
Minus 1I, that is minus I. Abi? Then 4J minus 2J. That is 4J plus 2, which is what? Plus 6J. Then the last one, minus 6K minus 0K. That's what? Minus 6K. And this is how to subtract two vectors from another. You can see, we subtracted vector B from what? From vector A. And we have our result here. Minus I plus 6J minus 6K. And this is how to solve question, addition and subtraction of vector. Now let us still go to another aspect of vector. But before then, do we have any question? Okay.
If it is inverse as in B, as it is there, what we did is A minus B.
Okay.
If it is now the inverse, B minus A.
B minus A, yes, thank you. I love that question. B minus A. Now here we have B minus A. That means 4 minus what? 3i. Now 4 minus 3i. 4i minus 3i gives us what? I. So we have I. Our I. Then minus 2j minus 4j. That's what? Minus 6j.
It's close.
Minus 2j minus 4j. That's what? Minus 6j. Now the next one. 0k minus 6k. It now gives us what? 6k. So this is the solution. Do you understand now? That's it. Now let us move on to a particular aspect of vector today. We call it the magnitude of vectors. Magnitude. You know, we said that a vector is a quantity having both magnitude and what? And direction. Now, we have all this. Now here we have what? Magnitude. That means how to find the magnitude of a vector. To find the magnitude of the vector, we make use of this formula. When we have vector A to be equals to a two-dimensional vector to be what? AXI plus AYJ. The magnitude of this vector A is written to be the magnitude of A equals the square root of AX squared plus AY squared. And this is gotten from Pythagoras theorem. Now let us take for example vector A, which is 2i minus 3j. Look at this. Now let us find what? Magnitude of A. So therefore the magnitude of A here will now be equals to what? Square root of what? 2 square. We are not using I. We're only choosing what? This. 2 square plus minus 3 square. So we have what? 2 square, which is what? 4 plus minus 3 square, which is what? 9. So here you have 4 plus 9, that is what? 13. So we have the square root of 13 as the magnitude of what? Of A. And that's how to find the magnitude of a vector. Do you understand that all?
If before we even add it up, can't we just say since it is 4 and 9, the square root of 4 is 2, the square root of 9 is 3, and we now add it.
Under software, we don't do that. It's only when we have multiplication sign
that we can do so.
Yes. But this one is addition. So, do we have any questions? You understand that all? So, this is how to find the magnitude of a vector, and this is where we are going to solve for today. My assignment. If my vector A equals 2i minus 4j minus 6k and vector B equals to I minus j minus k, now show that A minus B is not equivalent to B minus A. So thank you for watching the video, and make sure to like, share and subscribe. Thank you.